On this module, we're talking about what is climate change. Next slide. Okay, so definition of climate change is it's a change of climate caused directly or indirectly by human activity. And what is this human activity? It is us altering the global atmosphere. Climate change can be an increase in temperatures if we're releasing greenhouse gases, but it could theoretically also be a decrease in temperatures if we're releasing aerosols, things like sulfur dioxide will cause a reduction. Climate change is in addition to natural variation. What do I mean by that? Okay, so here is some data. It's always good to start with local data, which shows from the Malaysian Meteorological Department, it shows the record maximum temperatures recorded in Peninsular Malaysia, Sarawak and Sabah from 1951 up until 2019, and it's a temperature here. And what you see is some years sangat panas and some years are a bit cooler years. Okay, that is this natural climate variability. It's natural fluctuations. Some years you got hot, some years you got cold, some years you got wet, some years you got dry. The evidence for climate change, though, is if you see these trend lines, what you see is that the maximum recorded temperatures in both Peninsular Malaysia, Sarawak and Sabah are all on an upward trajectory. They're all increasing. And in fact, temperatures have increased in Sabah by about 0.5 degree in the last 30 years. Okay? So this is one bit of evidence that climates are changing. Okay? This is from the World Resource Institute, and it's from the assessment, the Intergovernmental Panel of Climate Change Assessment Report 6. And what it showed is that glaciers retreat has been unmatched for 2,000 years. So the glaciers are decreasing in size. Our last decade has been the warmest warmer than any period for the last 125,000 years. Sea level rises are increasing at rates faster than in the last 3,000 years. Our summer ice caps, Arctic ice is also smaller than it's been in any time in the last 1,000 years. Oceans are warming faster than they have since the last ice age. And we've also got this increase in acidification of the oceans. Oceans are becoming more acidic, and the records are it's more acidic than it has been in the last 26,000 years. So what we're seeing is the climate is changing and the environment is changing. And why is this? It all comes down to the greenhouse gas effect. Next slide. I assume most of you know about the greenhouse gas effect. Okay, greenhouse gas effect is essential for life on planet Earth. It is a natural process. Without the greenhouse gas effect, there would not be life on Earth. Okay, what happens is the sun emits solar radiation. This radiation, some of it is reflected by the atmosphere, reflected by the aerosols that we put out, but most of it strikes the Earth's surface. Okay, next slide. This energy that strikes the Earth's surface heats up the planet, heats up the oceans, is used for photosynthesis, and then is emitted as infrared radiation. So the infrared radiation leaves the Earth's surface, and without this layer of greenhouse gases, all of it would escape into outer space. Without those greenhouse gases, the average temperature of planet Earth would be negative 15 degrees Celsius. Okay? Water would not be liquid. We'd be living on an ice planet. These greenhouse gases, what they do is some of it does leak out. Next, okay. But a part of it is absorbed by these gases. And the gases we're talking about are water, carbon dioxide, methane, nitrous oxide, and ozone. And these gases up in the troposphere are sitting there, and as the infrared radiation comes up, it strikes a molecule. The molecule then becomes excited and it starts to vibrate, okay? And it accumulates energy, and then what it does is it releases the energy, okay? And that energy, part of it escapes into the atmosphere, and other parts gets re-radiated back down to the Earth's surface, into the atmosphere. And it's that which is warming the planet. Okay, so this is the natural greenhouse gas effect, and it's critical for life on Earth. Okay, without it, tirada orang, we would all be frozen. Okay, where the greenhouse gas effect becomes a problem, next, is when you increase the concentration of these gases. What happens is, did you shift it? Okay, more of the infrared radiation strikes the greenhouse gases. Less of the radiation escapes into the atmosphere, into outer space, and a greater proportion is radiated back to warm the planet. Okay? And this, the increase of carbon dioxide, methane, and nitrous oxide by humans is what's causing these increases in temperatures and these changes that we're seeing in ice caps and glaciers. And the difference between the first case, which was before we started releasing the greenhouse gases, and now where we've increased the concentration, is called, the difference in the amount of energy being retained is called the radiative forcing. Okay? And this is a critical term. We need to remember this term because when we start to talk about the climate change projections, I'll be talking about radiative forcings and we'll be talking about numbers. Okay? So I need you to have some idea of what these numbers mean. So to try to illustrate what radiative forcing means, I need 11 volunteers to stand up. 1, 2, 3, 4, 5, 6, 7, 8, 11 saja. 2, 4, 6, 8, okay, 11. Now, I'm planet Earth, and I've been under the sun all day, and I'm really panas, okay? And now what I want you to do is I'm about to emit the infrared radiation. And what I want you to do is to start to vibrate, and when you've plus vibrating, release the energy vocally, okay? What you have to do, you people that are standing now represent the pre-industrial era, okay? Zaman pra-industry, okay? Before we started releasing greenhouse gases, okay? So you 11 people represent that. What you need to do is keep your vocalization constant across the exercise, okay? So, okay, Bisimba. Okay, now we want to, in another 6 people to stand up. So the scientists have set the radiative forcing from 1750 as 0. Okay, so the pre-industrial era, the radiating forcing has been assigned the value of 0. Now we are at 420 parts per million, which is roughly what we are now. Okay, and so you 16 people represent the current conditions. So again, exactly the same thing. Okay. Now we're going to do the future. Actually, some of the future have already stood up. So if everyone can stand up, when there was 16 of you up there, that represents about 420 parts per million, or a radiative forcing of 2 something. I couldn't get defined figures from the literature. There was different reports. Okay, now when everyone's standing up, we're going to be trying to represent the future conditions under an emission scenario called SSP 245 with a radiative forcing of 4.5. And that is the condition that we seem to be heading towards at the moment. 2.7 to 2.9 degrees of warming. Okay, so. Okay. So the point of that exercise, you can sit, boleh duduk. So the point of that exercise was later on in the next module, I will be talking about numbers. I will be talking about a radiative forcing of 4.5, a radiative forcing of 3.7, of 7.0, a radiative forcing of 8.5. We don't have enough people in the room to model those, okay? But what it means is the higher the radiative forcing, the more energy that is being sent back to warm the atmosphere, and the hotter it's going to get, okay? So when you see the numbers, because I know some of you don't like numbers, you just remember that if the number's low, 0, it means it was times dulu, okay? If it's a value of 2, it's roughly about where we are now. 2.6 is going to be where we will be, well, we're already going to limp past that, but that's where we hope to be. A radiative forcing of 4.5 is where we're probably heading. And what happens is the higher the value, the lebih teruk it's going to be, okay? So you understand that we started at a pre-industrial global CO2 concentration of about 280 parts per million, okay? And we've increased it in the last, was it 160 years, to a value in excess of 420 parts per million. With this increased concentration in greenhouse gases in the atmosphere, there's been a corresponding increase in the mean, this is the difference between the temperature for the mid-century. So basically there's been an increase in the temperature. You see, of course, there's always been variability. In this part of the graph, climate change wasn't having any major impacts. There were some years which were hot, some years which were cold, but then in about the 1970s, 1960s, we start to see the graph accelerating up. Why do we see this massive increase in the concentration of greenhouse gases? Any suggestions? Yeah. Biggest one, population does contribute, but the biggest one during this time period here was where our oil and gas industry really took off, because you had the development of the motor car, and you then had the fossil fuel driven progress. The more cars we have, the more fuel we burn, and the greater the increase in CO2. Okay? There is evidence out there that CO2 rises, temperature rises. Okay, next slide. If you start communicating this, you will come across people that will be denialists. Okay? And some of them range from people that think it's a whole CIA plot. Others accept that climate change is happening, but they question whether it's actually due to human activity. Okay? Is it us burning fossil fuels or is it natural? And this is going to be one question you will be asked. So what the IPC scientists have done is they've looked at the possible drivers of climate change, both man-made and natural. The black line, time on the bottom, and this is the temperature difference from the average. It's in Fahrenheit, unfortunately. So black line showing the increase in temperatures. And then what they've done is they've tried to quantify the effects of different drivers. Okay? Volcanoes, solar, and orbital. Okay? If you look at the volcano, they have quite a mixed effect. Whenever there's an eruption, the volcanoes actually reduce the temperature increase because of the aerosols. Okay, they're releasing heaps of, dust, also sulfur dioxide, which basically cause light to be reflected. Okay, so when was it this is I think Mount Pinatubo, is it? The volcano in the Philippines. When that erupted, it had a global impact on climate. But normally volcanoes are a source of CO2. So if they're just sitting there doing nothing much, they increase the greenhouse gas effect. If they blow up, they decrease it. Solar, this is just an indication of the output from the sun. It does vary, but you see it's relatively constant. And this is variations in the Earth's orbit. What happens, the Earth doesn't spin like constant. Sometimes it sort of jiggles a bit. Okay, and so you get slight fluctuations in the heating input. Okay, next. They've also looked at how humans influence climate. Okay, aerosols, us polluting the atmosphere with sulfur dioxide and other things actually has saved us a little bit because it's reduced the greenhouse gas effects. Because these aerosols are up there and they're helping to reflect the sunlight coming in, they cause a reduction in the heating. Land cover, this is thought to have a negative effect as well, because one of the consequences of climate change is that certain areas in the globe have had more rain. And there's evidence of parts of the globe where you're seeing an increased greening, okay? And that's increase in CO2, intake of CO2, etc. There's also ozone, but the big one, of course, is our greenhouse gas emissions. All of the rise, or most of the rise in our temperatures are due to these. But we're not paying the full effect. Our greenhouse gas emissions are actually greater than the impact of the whole man-made drivers. And that's because they've been offset a bit by these aerosols. Look at that. How many of those acronyms do you understand? If we asked you to write out the names or what these mean, I think most people would struggle. It is taken from this website, The New Humanitarian, what climate change acronyms mean. And he starts his article FFS, there's a lot of climate jargon. And now what I'm going to do is I'm going to pass over to Eric to talk about some of these terms, particularly the UNFCCC, IPCC, COPE, and maybe a little bit on this AR stuff, okay?
So I'll be presenting all of these terms when you deal with climate communication, everything. So all of these funny acronyms will pop up. So you guys have to know what this is so that to better understand how the global stage is dealing with climate change. So first, before we go into the acronyms, I'm going to introduce you to the two big ones. So the two big ones are the IPCC and the UNFCCC. That's 3 C's already. So basically, these two are the two big things that handle the international action on climate change. So the IPCC, or the Intergovernmental Panel on Climate Change, is basically a group of experts that monitors all the scientific advancement on climate change. They monitor climate change, what's happening, what's the concentration in the atmosphere, what records are getting broken because of the result of this, and sometimes they recommend policy on how we can mitigate this. So basically, this part here, this is the group of experts that monitors climate change. And this group of experts, sometimes they will publish assessment reports on climate change. These assessment reports, usually they will compile all the latest findings, all the latest findings about climate change, the newest calculations, the newest models. Again, everything will be compiled here by a group of experts. So usually a lot of our terminologies that you see here, like say the SSPs, your social economic pathways, your those things, they are the ones responsible. So all those big numbers and everything, you can blame all the scientists here. They are the ones responsible for navigating the complex sciences behind climate change and what's happening. And then they help us. Here, the United Nations Framework Convention on Climate Change, they are the policy makers that decide climate policies that countries around the world have to follow. So the IPCC, usually through the assessment report, usually help guide the policymakers here to decide on what policies we should do on climate change. So all those big conventions, all those big treaties about climate change, all the policymakers that represents the countries around the world will gather here and discuss what's the best course of action that the globe should take. So just bear in mind, both of these are under the UN General Assembly. So again, this is like the highest body you can ever get when it comes to climate change. So all these countries around the world, usually once a year, they will gather in what is known as the Conference of Parties. Here they will discuss again. Usually the scientists will present the latest findings in climate change here in this big conference. I think last year it was in the United Arab Emirates. This year will be somewhere in Azerbaijan, yes. So here are all the latest discoveries by scientists, where we're heading in the climate. The scientists will present here. And then the policy makers from the countries, from the UN, they'll decide what's the best course of actions the world should take in terms of policy for how we should tackle climate change. So during the COP 2022, where the Paris Agreement made, one of the policies that came up from the Conference of Parties are the nationally determined contributions. So this is, since the Paris Agreement is legally binding, so once every 5 years or something like that. So a few years, all the countries have to state what is their plans to mitigate their emissions, and every time they have to update whatever contributions that they made from the last time have to be better in the new one. So again, these two are the big things that you have to remember. So here you see the timeline on climate action. So a bit of a depressing timeline if you ask me. But yeah, so I'm just going to go through. So again, since a lot of our monitoring projection comes from the pre-industrial levels. So pre-industrial, again, that is roughly the era where it happened, the revolution. So again, we'll see all of that. So, but back in 1896, more than 100 years ago, scientists have already understood that CO2 can have an effect on the climate. Again, here you have your large scale extraction, and then all the way back in 1960, this is when we first tracked the atmospheric CO2 in the atmosphere. Because we knew way back then, we already knew something was greenhouse gases was already affecting the climate. So again, in 1988, the United Nations, they established the IPCC, and the IPCC in 1990, this is their first assessment report. And in this assessment report, they state that human actions that are warming the planet. But then it took all the way until 2007, 17 years later, doing the fourth assessment report that scientists finally unanimously, unambiguously say human activities are causing climate change. So you can see how slow it is for us to tackle climate change. It's very depressing, but that is how slow it is, and this is why we must take action very, very quickly. It took 17 years for scientists to say that that human activities are definitely warming the planet, even though all the way back in 1896 we know that greenhouse gas like CO2 does affect the environment. So again, the UNFCCC, the guys responsible for making policies and climate treaties were established in 1902. Their first COP was in 1995. And Kyoto Protocol, that is probably some of you probably be familiar with it. So in 1997, that is when the countries around the world adopted the Kyoto Protocol. That is the first, let's say, climate treaty that tries to tackle our emissions. But this was not legally binding, so not a lot of countries actually follow through. So then in 2009, here in COP15, this is where scientists already say that our global temperature should not increase above 2, and preferably 1.5. And then finally, in 2015, only then we had a legally binding climate treaty known as the Paris Agreement. So since it's legally binding, all countries have to follow whatever the Paris Agreement says. So what is the Paris Agreement? So basically, there's three main things that you can see in the Paris Agreement. So the most important thing, again, is warming. We have to achieve warming below 2 degrees Celsius from industrial level. And by mid-century, we must reach net zero. So yes, this is the big thing in the Paris Agreement that all countries, all signatories have to commit to. So another big thing that in the Paris Agreement is, again, enhanced resilience and adaptation to climate change and adaptation to climate impact that is certain to occur, and also align financial flows in the world with these objectives. So basically, in the third one, for the poorest countries that could not adapt, there's supposed to be like funding for them to help adapt. So basically, these are three big things that we can see in the Paris Agreement, and this is legally binding. So all countries all signatories is supposed to follow this. Suppose. So again, because we always hear 2 degrees, 1.5. So what exactly does it mean? So basically, even though the Paris Agreement says below 2 degrees Celsius, basically what is preferred is actually 1.5. So 1.5 degrees Celsius, you can see just how stark of a difference in a 0.5 degrees warming. So this is what. So basically, if it's 1.5, the one that you always hear scientists say we must achieve, we must at least limit to. Your global population is only 14%, but under the 2 degrees, it's 2 times worse, it's 2.6 times worse. So again, maize harvest, 2 times worse under 2 degrees. Sea level rise is a bit much higher, which increased the risk to 10 million more people. And then fisheries, again, more will affect. Basically, even though the Paris Agreement says 2, this is why we push for 1.5.
The Paris Agreement created a legal framework for the governments to put concrete action into addressing climate change and increasing resilience. Okay, so when you signed on to the Paris Agreement, you agreed to, first of all, you turned up to the Paris Agreement with what were referred to as intended national determined contributions. Okay, and this was what you were going to do. Malaysia's NDC in 2016 was to reduce greenhouse gases by 35% in emission intensity compared to of the GDP relative to the 2015 level. What does that mean? It means 2005 level. Okay, if in 2005 you released 1 ton of carbon dioxide to earn 1 million ringgit, okay, in 2005, then by 2030, I think the timeline was, 2020 was it? Okay, 2020, you were meant to have reduced that by 35%. So you'd release 650 kilograms of CO2 to earn your 1 million ringgit. We then updated in 2002 to, by 2030, to have reduced our greenhouse gas intensities by 45% relative to 2005. So again, if you're using 1 ton to produce 1 million, now you would be releasing 550 kilograms to produce 1 million ringgit. This doesn't mean you're reducing emissions. Okay? You can, in fact, be releasing more greenhouse gas emissions because your GDP has increased. So if you've doubled your GDP in that time frame, then you'll actually be emitting more emissions. Okay. With the Paris Agreement, Malaysia has to update their NDCs every 5 years. And the good thing about the Paris Agreement is that your NDCs have to be as good or better. So your next update, you can't go back to here. You have to either be this one or promise something slightly better. Okay? And they'll be doing this every 5 years up until 2050/2060. Okay? With the idea that by 2050, Malaysia will have net zero emissions and be climate resilient. The original discussion was about 2050, but it sounds like Malaysia, like a number of other countries, is going to probably push that back to 2060. Along the way, you also have to submit evidence that you're doing what you promised. Previously, I think from Kyoto, you had your national communications, and then initially, I think from Paris, you had your biannual update reports. Starting at the end of 2024, Malaysia will have to produce something called a biannual transparency report. So you'll be, again, just reporting about your greenhouse gas emissions. You'll be reporting about your steps to climate resilience. But the difference is these will be being peer reviewed. And I think like most things that get peer reviewed, they then get sent back to you for tambah baik. Okay? What does this mean for Malaysia? Well, from the BUR, biannual update report, the last one, Malaysia's greenhouse gas emissions were about 330,000 gigagrams. A gigagram is 1,000 tons, okay? So that's 330,000 tons. The greenhouse gas emissions are a mixture of carbon dioxide, which is roughly about 60%, methane, which according to Eric's calculation is about 32%. This is in terms of global warming potential, not the amount emitted. So we've standardized across the global warming potential. And then a few other gases like nitrous oxide and your fluorinated gases, okay? If we want to become carbon neutral, which is what we'll be doing in tomorrow's exercise, it's where you abate, where you account for all your carbon dioxide emissions and you do some sort of offsetting. So you become, how much you're emitting is taken in. You're sequestering that amount. So the balance is neutral, but it's only dealing with carbon dioxide. In the NDCs, the National Determined Contributions, what we've promised is net zero. So in that, we have to address methane, we have to address carbon dioxide, we have to address nitrous oxide and the fluorinated. And then what we need there is the amount that we're emitting is equal to what we're sequestering. Malaysia's main sequestration strategy are our forests. We emit 330,000 gigagrams of CO2. We claim that our forests are sequestering something like about 200,000 of it. Okay, so most of our 2/3 of what we emit is being taken up by our forests. Okay, we have some queries about those figures. If we want to achieve this figure, then what we actually have to do is reduce all of these by another 150,000 gigagrams, okay? And so that's why, addressing things like methane is an extremely potent greenhouse gas. It's got a global warming potential, 28 times that of carbon dioxide. It's also something which can be solved quite easily because most of it comes from, in Malaysia, the emissions from our palm oil mill effluents and also leakage from our oil and gas and then landfill, etc. Okay, that's a relatively easy target to solve. Reducing CO2, which is primarily from energy. It's our burning of fossil fuels for power. It's use in industrial processes is probably going to be a little bit more challenging. But there are policies in place and increase of renewable energy, etc. These other ones I'm not less familiar with. Okay, so this is what the NDCs mean for Malaysia.